Introducing you to 3D figures means that you're going to be exposed to lots of vocabulary, lots of pictures, so make sure you have plenty of notebook paper, a good straight edge, and a sharpened pencil. First thing you need to know is that a three-dimensional figure has exactly that, 3 dimensions. It has length, width, and height. When we're talking about a face, we're talking about the flat surface of a 3D figure. So I'm going to use this tissue box as an example of a 3D figure. The face are the flat sides of it. So this right rectangular prism here would have 6 faces. The edge are where 2 faces meet, like the corner. Just like what the word edge means in real life, it's the same thing as what it means in geometry. A polyhedron is a 3D figure whose faces are all polygons. I'm going to contrast that with this marker. This marker here, let's pretend that all this is flattened off right here and it is a perfect cylinder. It would not be a polyhedron because it has a base that is a circle. The right rectangular prism would be a polyhedron. The vertex is the point where 3 or more faces meet. Think about a pyramid. That point at the top would be called the vertex. Or on this prism right there could be called a vertex because I have 1, 2, 3 faces that are meeting at that corner. The base is the face used to name the polyhedron. So we'll be talking about the marker, talking about this prism here. Notice I call it a rectangular prism. Its base is right here and right here. 2 bases, and I call it a rectangular prism because of that base. I could also have a triangular prism if this side were to be a triangle, or I could have an octagonal prism. The base is how you're going to name the polyhedron. Polyhedrons are split into 2 categories. They are either prisms or they are pyramids. A prism is a polyhedron that has 2 parallel congruent bases, here and down here. They're parallel and they are congruent, the same shape. These bases can be any polygon. So like I said, I could have a triangle, a rectangle, a pentagon, a hexagon, a heptagon, an octagon, a 24gon. You could have anything that's a polygon as your base. However, all of the other faces are going to be, and actually that should say parallelograms. Let's change that real quick. Okay, my apologies. It would have fit better if I would have noticed it beforehand. They are parallelograms. In this case, they're rectangles, and in most that you're going to see, they're going to be rectangles. So there are 2 examples of prisms. Now the trick to drawing a prism is to draw the face that's closest to you. So it'll be like this face here. So I started with a rectangle, and then if you'll think back to art class, you come back from those vertexes and you draw parallel lines. You'll notice that my diagonals are all parallel, and that's how you connect them. If you don't want to draw the dashed lines in the back, that's okay. That just kind of gives it some more depth though. This one here that looks kind of like a tent, this is a triangular prism. I started with my triangle here, came off with the diagonals, and then connected them. In the blue, we're going to talk about pyramids. A pyramid is a polyhedron that has 1 base. So you can see down here I have a rectangle on the bottom here and a triangle here. That base can be any polygon, so like how it was with the prism, I could have a 22-agon pyramid, something crazy like that. But all the other faces are going to be triangles. So the trick here is when you see a triangle as part of a 3D figure, not assuming that it's a pyramid, because you could have a triangle part of a prism and those triangles being the bases. Here are 3 figures that are not polyhedrons. A cylinder. Cylinder has 2 parallel congruent bases that are circles, the top and the bottom. And actually what goes around the other side, it's not necessarily a face, but it would be a rectangle if you unrolled it, as you would in a net, which we'll look at in surface area. For cones, a cone has 1 base, it's a circle at the bottom here, but instead of having another circle on top, you have a point at the top called the vertex. It's where the rest of the surface comes up and meets. And a sphere, this is like a ball. A sphere has a surface that is made up of all the points that are the same distance from a given point. That seems like a very confusing definition, but picture the top of my finger here being that point. And the sphere, we'll turn around this way. If I had this marker open and I were to just color all around there and all the places that the marker tip hits, that would make the sphere. And I'm not even getting close to touching all those points. But if you were, that's what a sphere would be. Like in a circle, you have a point in the middle, and it goes two-dimensionally, and it's all those points that go around it. A sphere is going in all 3 dimensions around it. Classifying 3D figures is the action of this lesson. This is what you're actually going to be doing. To do this, you're going to name as a polyhedron or not. So you ask yourself, are all the faces polygons? If your answer is yes, then it is a polyhedron. If your answer is no, such as with the cylinder, I have a circle down here, then it's not a polyhedron. Then you're going to name the figure. Polyhedrons are named by their base. Notice I might have said triangular prism or rectangular prism or a rectangular pyramid. Polyhedrons are named by the base. The figures that are not polyhedrons, that's going to be your cylinders, your cones, and your spheres. So you're going to name that polyhedron based on the number of bases. If it has 2 bases, then it's either a prism or it is a cylinder. A prism has a polygon base, a cylinder has a circle base. If it has 1 base, it is a pyramid, meaning it has a polygon base, or it is a cone, meaning it has a circle base. If it has no bases, then it is a sphere. So here's your chance to practice this. You're going to classify each figure as a polyhedron or not, and then you're going to name the figure. Okay, practice A, it is a polyhedron because all of its faces are polygons. They're all triangles. There is only 1 base. It comes to a vertex at the top. The base is a triangle, so it is a triangular pyramid. For B, it is not a polyhedron because I have a circle here and down here. It has 2 parallel bases that are circles, so it is a cylinder. Part C, it is a polyhedron. All of those faces are polygons. The bases, I had to count 1, 2, 3, 4, 5, 6, 7, 8. It has 8 sides, so it is an octagonal base, making it an octagonal prism. And D, I gave a description instead of a picture. All points on the surface are the same distance from a given point, and that is a sphere, and a sphere is not a polyhedron.